Hi everyone, I am Siva Prasad, working as an associate professor in CSE department in Guntur Engineering College. In this class, we are going to discuss about building system from the off-the-shelf components in software architecture and design pattern subject. Off-the-shelf components. What is the off-the-shelf component? Generally in our day-to-day life, we are listening the word shelf. So it is like a ready-made component. How we are picking the components from the shelf and utilizing it in our day-to-day activity. In the same way, there are some components which are developed in the commercial manner or developed by open source softwares to be used by other systems in the ready-made fashion. We call it as off-the-shelf components. So it is also shortcut format is OTS, off the shelf components. It is usually provided by a commercial vendor or open source software. So just we choose the required component and we can use it as per your requirement. Such a component is usually has been used in many other systems and should have a fewer defects or have had more bugs shaken out of it. That means these components are not defined for only one purpose, are not defined for only for one software. The components which are special in the nature, they designed for using of any system. For example, if you consider bike tires, so the tires TVS company or MRF tire company produces one bike tire. The tire can be used by TVS company or Honda company or Bajaj company, whatever it may be. That means they are developing some components with some general requirements. These components can be used by any other component. You can call it as off-the-shelf components. In the same way, in the computers also we have number of plug and play components. Just we load the software and we can use it for our requirements. The main advantage of the COTS, so commercial or commercial off the shelf softwares, we call it as development cost is reduced and development time is reduced. Complexity of the system can be built by reusing pre-existing components. Testing effort is reduced as we need not to develop the components by ourselves. Just we use the component and in our software system, so we are able to reduce the time, reduce the cost, and main thing is it is very easy to deploy. They are already proven systems. That's why many of the software developers are using OTs or COTs. OTs means developed by open source systems. COTs in the sense commercial off-the-shelf softwares. Like that we use. For example, if you consider China, the China government has constructed COVID hospital within 10 days, within 11 days. Already you might know that some 1000 beds, 1300 beds like that. Matter of 10 days. They have used prefabricated structures. The open, the on off-the-shelf components are also working like prefabricated components. Just we pick up the right component, place it in the right position so that we are able to perform the work in a quicker manner. Already you know about China has constructed one building within 10 days. So like that we in the software field also we reuse the existing components or we reuse some commercial components. Building systems from off-the-shelf components. Systems are being constructed with more and more cost of the shelf components for economic reasons, because the cost is reduced. Main our human resource cost is reduced and time is also reduced. And one more thing, quality attributes, as this OTS off the shelf components are already proven, already they have proved their performance. So it is better to use the OTS so that we can improve the quality. Off the shelf diagram, you see the off the shelf components provided by some component provider. So there are different component providers providing off the shelf components. As an integrator, we need to choose the right component. Right component in the sense we need to select the component, and that component should be integrated with the existing system, and the component should be maintained in an appropriate manner. Selecting the component in the sense what component is most suitable for your software, that you have to select. For example, when your bike tire got repaired, you want to replace your bike tire. Do you purchase any tire? Do you go for specifications? Yes, there are some specifications. For example, Pulsar bike front tire. Okay, they give some specification. The same Pulsar bike tire can be used for another bike like Charisma, etc. also. So we choose the compatibility list. From the compatibility list, there are number of tire manufacturing tires. So we choose the suitable tire for your bike, and that is called as component selection. And that component is integrated into your vehicle, and that should be maintained in an appropriate manner. In the same way, in the software development also, you need to select the right component, and that component should be integrated with your system, and that integration should be maintained in an appropriate manner. At last, you are delivering it to your customer. Customer is going to use your entire software. It requires it requirement process needs to be more flexible. It very important thing, flexibility. It allowing what is available in the marketplace to modify the requirements to provide a better overall business solution. For the systems built from the OTS, off the shelf components, component selection involves a discovering process which seeks to identify assemblies of compatible components. You need to concentrate on compatibility list, understanding how they can achieve the desired quality attributes, and detecting whether they can be integrated with the system being built or not. That should be very important. So there are some mismatches. Even though the components are developed for ready to use, but all the components may not fit your requirements. Just as I have given bike tire example, all the tires may not match with your bike requirements. So you need to go for compatibility list. From that compatibility list only, you need to select the suitable components. So you see, all components work together. Not all components work together even if they are commercially produced. Commercial products that claim compatibility, sometimes they say it is compatible, but it may not match with your system. So some API problems may occur. API, application program interface problems may occur with your system. Components that were not developed specifically for your system may not meet all the requirements. Architectural mismatch usually shows up at the system integration time. The system will not compile, will not link, or will not run. Sometimes it is giving the errors at the runtime. So it is an issue. Like that, we have number of issues. So what can we do about interface mismatch? For example, there is an interface mismatch. So what we can do? You see, there are three techniques: avoid, detect, and repair. Avoid by carefully specifying and inspecting the components for your system. That is from the compatible list only you need to select. From that compatible list, you need to detect the suitable component. Those cases you have not avoided by careful qualification of the components, you may be facing problem. Repair, the you have detected adapting by the components. If it got any repair, it should be repaired. That means that should be maintained in a proper manner. Techniques for repairing interface mismatch. When there is a mismatch in the interface between these components, you need to follow some techniques to avoid the interface mismatch. There are three elements: wrappers, bridges, and mediators. Wrappers, already you know about wrappers. Generally you are eating wrappers, biscuit wrappers, chocolate wrappers, etc. So the term wrapper implies from an encapsulation. We can interpret interface translation as including translating an element of a component interface into an alternative element, hiding an element of a component interface, preserving an element of components based interface, without changing. You need to wrap up one element with another element with the help of some glues. Here API is working like a glue. Next, bridges. The bridges translate some requires assumptions of one arbitrary component to, to some provides assumption of another one. The key difference between bridge and wrapper is that repair code constituting a bridge is independent of any particular component. Repairing of bridge is independent of any particular element, particular component. That is not the case with the wrappers. Next, third one is mediator. Mediator exhibit properties of both bridge and wrappers. The major distinction between the bridge and mediators is that incorporate a planning function. Mediator main thing is it planning the functionality. Next one is techniques for detecting interface mismatch. Discovering all of the requires assumptions of components for each of the service that will be used by the system. Making sure that each requires assumption is satisfied by some provides assumption in the system. Techniques for avoiding interface mismatch. One technique for avoiding the interface mismatch is to undertake from the earlier phase of design a disciplined approach to specifying as many assumptions about components interface as feasible. Assumptions stated assertions about the sufficiency of the service provided by each module and implementability of each service by identifying resource as necessary to the module. For example, consider this diagram. So for this model problem, there are some actors like architects, engineers, etc. And these architect and engineers will try to identify the problem. Then the architect engineers identify the design questions. The architect engineer define the starting of evaluation criteria and they define the implementation constraints. What are the problems to implement these issues that will be detected by architects and engineers. And they develop a model solution which is suitable for this context. And they identifying the evaluation criteria. The architect performs an evaluation of the model solution against the ending criteria. Thank you.